I've got my green screen set up. Looks like I have a little bit of a weird spotlighting effect over there. It's been a long time since I've used a green screen. I had it back down in the basement when I was streaming down there, but then after the accident, I moved up into a room upstairs, and it's a lot warmer there. Um, Green screen back? Is it Oh yeah, it's definitely back. It I think it's because so I'm only using the other like I've got studio lights too. And I think I've haphazardly sort of placed them around the room wherever I can fit it. And it's sort of next to the green screen over there. So I think that may not be the best place to put it. Danny Fritz, good morning. Yeah, the accident sounds like a book. Yeah, I guess in a way it does. But luckily I've been able to recover, for the most part. So I'm back to being able to code. Okay, so today the plan has been to well, maybe not that. Like maybe a little bit more like sort of information about like what's been going on. We're on oh, you're trying bang today. Yeah, I don't have a bot. So none of the commands will work. Um I I spent 9 parts trying to get through the chapter 2 ecosystem project. And the problem that we ran into was that we're not able to delete walkers as they eat each other. And it's a problem of like the walkers have to detect each other, and because it's an array of essentially instances of structures, that's an entire problem. So I actually reached out to a mentor, and well, specifically, I reached out to Danny, who is here. So, Danny, thank you over the weekend for giving me some hints of what to look into, specifically restructuring the way I'm organizing memory. So I can actually switch over to the other feature that I've added. All the light. Okay, so I realize that the light here is not necessarily helping out this. Let me try changing the direction that's facing really quickly. Not necessarily that much better. If I turn it off, what does that look like? That part looks good. This isn't too bad. All right, I'll just try running with this for right now. Anyway, so I've got a new feature of the studio here, which is a whiteboard. So the only negative is I don't have access to like chat when I'm in this room because of where I've got the displays. But the idea here is we previously had a vector, and I need to make sure that that's, yeah, perfect. We had a vector of essentially instances. And so that would be something like, okay, we have position, and then we have our velocity and whatnot. And we have a bunch of these. And those are our walkers inside of this single array that we'd have to loop through and then figure out, okay, which one of you are dead? Let's now remove you from this array. Well, that turns out not to really work too well because, well, I'm kind of manipulating an array that I'm kind of into. And each of these they're not objects per se, but rather instances of a structure. Each of these structures are not necessarily, like they're duplicating data and everything else. So Danny Fritz suggested, how about I look into something called ECS? That's ECS, Entity Component System. And the idea here is that we're going to switch our data structure over from an array of these structures like this to an array of data, with each data being for a different purpose. I guess like not an array in this case, it's going to be a vector, but in different languages that might be an array. And so let's just say that this is going to be our position vector. And that means we're just going to have maybe point 2. Now it's the same type over and over and over again, and then we might have a velocity. And that's going to be the exact same thing. So this might be like a point 2. And so on. So every single data point has this down. Now, this is the super basic, simple one because I'm still learning how this works. And the idea is that this would be like walker 1 is like this thin slice all the way down. And so I could say, hey, I need position and velocity for each of the walkers in turn. Well, it's just going to grab position 0 of the position vector and of the velocity vector at the same time. Let me do the calculation, update the position, and now move on to the next one, and the next one, and the next one, like that. Now with that, then deleting them becomes a lot simpler. Or at least that's the idea. So I hope that all came through. Well, so familiar with ECS concepts. Basically, what happened was I just watched a whole bunch of presentations this weekend to sort of learn about it. There was a really good, it was actually on the library we're going to use, a meetup from Auckland that I thought that really helped a lot. And then there's a couple other ones. So you watched that one too? Awesome. Am I going to play with Amethyst? So Space Aliens, good morning first. Not exactly. What I want to do is I want to stay with GGEZ. I want to stay with there because, well, I really like GGEZ. If I can, then I'm going to stay. If I can't, then I might switch over to Amethyst. Because it implements specs, which is a library in Rust that for ECS by default. Still a little bit hot. Okay, so the library in question. It's the specs crate. It implements ECS, and as sort of Space Aliens suggested, Amethyst uses specs by default behind the scenes. Amethyst announced last night they're switching to Legion from specs. Wait, is Legion another? Oh, so if we have trouble with specs, maybe we could try Legion. I'm just sort of beginning into this ECS world. So if they're switching away, probably not right now then, to even play with Amethyst. I'll wait until they stabilize with this before I try them out. All right, well, so there's a couple of these. I'm going to stay with specs for right now, but that's just because what I've been trying to learn in this weekend. And so I went through about half of this book. I got a little bit just to sort of get an idea about what's going on and how things are working. And I wanted to try to integrate this with GGEZ. I'm glad that Danny's here because he has actually done this before. He sent me a repo that has GGEZ integrated with it, but I did notice it's a really old version of GGEZ and things have changed since then. So moving from GGEZ to Amethyst, not right now. We're gonna see how easy it is to integrate into easy it is to integrate into GGEZ with specs first. Okay, so with that all out of the way, let's sort of like get the basics, because I wrote a bunch of code in GGEZ to try to integrate specs last night, and I just got an error. So I'm going to move a little bit slower this morning and try to get it working properly. So let's go ahead and cargo new learning specs GGEZ. I also got my capture card working again, or not capture card, the splitter working again, so I'm able to use my big display, which is super nice. Okay, so we have everything here. One thing I did realize last night is that the run command that we have with the BB GGEZ is not really going to be all that helpful to us. So we'll see in a very short bit. But I'm gonna do my G main. So our name of crate, learning specs GGEZ. Okay, so, and we're gonna specifically bring in the game state. I guess I just call it game. These are, oh, I need to bring in we are using the 1.0.0, the one that Katali helped us make. So with that, we pull in we're just forwarding GGEZ from, or re-exporting from BB GGEZ. Okay, and that lets us have like conf, all this stuff. What else am I missing? Our title, so this is gonna be learning specs, GGEZ. All right, so that should be the basics here. We gotta wait for RLS to finish compiling everything so it can actually know if this is gonna be okay. The other thing is that we need our main library. And we need to create a game. So public. Stacking, you're ready for the big reveal. How did it go? Not very well. I came really close. I was able to get them to eat each other. I was able to, well, to know that they're eating each other, but I couldn't remove them from the array because I ran into too many sort of like reference problems, and deleting from the array or from the vector when it's in the vector and looping through it, and then it's doing like a double loop through, and there's lots of clones, and so I put them into boxes, but then boxes can't implement clone easily, so then we went down that rabbit hole, and eventually I just I was going to look through it this weekend to try to figure it out, but talking to Danny Fritz here in chat, we decided to move with ECS, a completely different way to store the memory. And I'm implementing specs for ECS. Okay, so game. Right now, we're not going to put anything in here. In fact, I think I need glib. So you are. Okay, so re-export you. We have our struct game. We have a new function that we're going to be back using again. So we're not using you right this second. Underscore u. The delta time is going to be important eventually. I guess maybe not right now. We don't need that. All right. Timer. We don't need you. Okay, so no errors in here. So I should be able to run this. And after it runs, I should be able to get, well, it should just load up a black sort of background for me. And while we wait, how was all of your guys this weekend? Did you do anything interesting? Learn anything interesting? Yeah, sounds like a linked list example. Where you can go down a deep rabbit hole and don't want to. Yeah, exactly. In the stream preview, you saw a whiteboard. Did you buy one? I do have. So I had a whiteboard previously. I realized that the microphone for the whiteboard view is over at the whiteboard, so I can't. You won't be able to hear me as well. I had this previously, and I just sort of actually mounted it in the wall next to my desk. I had to sort of rearrange things around, and I had a tripod already and another camera that's sort of delicately sitting on top of the tripod, and it's pointing at that. So that's I think that works pretty well. Denny Fritz, you ate bagels and are planning for an upcoming vacation, right? That sounds like it's gonna be really fun. Also, bagels are really nice, and I'm really sad that I can't eat them. All right, so that's working. We have like the basic game. So let's go ahead and implement a I guess like a very basic version of specs. So in here, we're gonna bring in, I think it's specs equals, and then it's this like object syntax where it's I forget what it is. Let's go look it up. This specs version, and I looked last night. It's actually 0.15.1 now. Features, and then we want to bring in specs derive too. So save that, let RLS start figuring that out. Okay, so moving into the main library, what we want to do is create a world that we're going to put these sort of components into. So I guess if we go back to the to here, and Danny, I know you've used specs before, so if I get this wrong, let me know. I think the idea is that each of these are going to be like essentially either entities or components, and systems are going to be what updates these, like functions that update them. And so if we have we're going to want an entire sort of world that these go into. And so if we want to just put a ball, like a circle, right in the center, we're going to need a position. We're going to need like a position, maybe a color, some kind of rendering system. But most importantly, we need this world, and we need to inject like these into the world to then be used by the entity, which would be the circle. So that's the first thing I'm going to do, is the world. As in the specs world? Yeah, this is the specs world. So let's use specs world. And I think we also need world extend ext here. Okay, so our public struct game, we're going to have world, and this is going to be a type world that we're going to store. And when we create a new game, let's go ahead and create the world. So it has to be a mutable world, I think. New. And we haven't put anything into it. A world is a collection of entities. It does bookkeeping on entities and their components, allows you to perform queries for your systems. Yeah, and I think like that's what I was trying to get at, but not quite so eloquently, apparently. Okay, so game, we're now just gonna put our world inside of the game. Of course, we're not really doing anything with world yet. So we need to add, I guess we need to add some components in here, and we also need to add an entity. So what I'm thinking is we'll add an entity that has the position in the center of the screen. Okay, so what does that mean? I'm gonna come down here. I'm gonna put these all into library right now because I'm not necessarily sure how I want to break these out into different files in the future. So that might be a future exploration. Okay, so we're gonna create a struct position. And I'm thinking we're gonna bring in use BBGZ. This will be GGEZ and algebra. We can actually make this a little bit easier here. Context, game results, graphics. Oh, before I forget, I'll turn this on. I already forgot, so. Okay, so then I want to bring in an algebra, and then I'm gonna want a vector 2. Because that's what I usually store, a vector 2. So position, I could do like an entire structure type thing, but I could also just do a tuple position and make this be a vector 2 of F32s. And what I want to do is say that you I want to derive this as a component from specs. Now something else that I can do what's it yelling at me about? Can't find, so then I need to bring in the type of storage that it's going to use. So I can actually, right now it wants to use dense vector storage. I think for like this example, let's just use normal vec storage. Mainly because I haven't played with dense vector storage yet at all. So we're gonna say storage is vec storage. Okay, so here's what's happening. We're gonna have the structure. It's gonna be a tuple struct that holds a vector 2. We're telling it to be a component, a spec component, and we're also telling it what type of storage to use, which is they're gonna put them in at a vec storage. Okay, so I need to, do I even need to implement anything for this? Probably a new. So let's implement position. Public function new, we can just bring in an X, F32, and a Y. We're going to return a position. And what this is going to look like is just position vector 2 new X and Y. Okay, so that gives us our position structure. And so now we need to, I think it's register. Let's take a look. Yeah, so we're going to now register that position into the world and make it available to everyone else. So that's going to be up here. So when we begin this, we're going to say world.register. And we have to give it the type. Yeah, register the type. So turbofish syntax, we're going to say it's type position, just like that. Yeah, exactly. If we wanted to register other components, then that's where we would do it too. And then I need to add an entity, which is going to be our circle, which is this. So create entity and then with. So I'm going to move this over to the other screen so I can review it. Or I could just move it over here. I realize that's how I usually do it. Okay, so world register. After we register this, let's now create world.create entity. And we're going to say with. Then it's going to be like the new type, like an instance of the type. So we're going to say position new, and let's just do like 100.0, 100.0 to begin with, and then .build to build it and store it inside of the world. With doesn't exist, so I think we're missing. Is it builder? It's builder, okay, perfect. So I have an entity in our world, and we have a component in our world. And now I need a system in order to get that component out and actually display it. And so I'm not going to do what I did last night, which was attempt to like actually render it and create all those stuff, I'm just going to see, I'm going to follow like sort of their example here and see if I can console log inside of the, I guess we could start inside the new function here and then move into the update function and then draw function if we, if we can. So we need a system, struct. This is going to be, I know already for the system. So we're just going to say this is print position. Like that's our print position system. It's an empty structure. And the reason for that is that we're going to be iterating over the rest of the world here. I guess not the world, but like those, the position vector that we need. So let's bring in system. So this is interesting. We need lifetimes here. So implement system for print position system. And then I also need to set the type. So type system data equals, and this is almost always a tuple, where now I get to tell it how I like what I want in this system, like what I want to have access in here. So let's actually move this multi-linus because this is going to get specs. We require a lot of things from specs. Okay, so in here we now need read storage. So I want read storage. I need to give it the lifetime, and then also the struct. And that's all I'm getting here. And now I can create my function run. Query for entities with a position component to operate on. Okay, that's what it's doing. So I'm telling it, iterate through the position sort of vector that it's created for me and give me all of them one after the other. If I had other ones in here, like another read storage, it would say like, give me the same position like down at that time. But that will probably come later. For right now, we need to like actually get this. Match, good morning, hello. Okay, so function run, we need a mutable self. It has to be mutable self, that's a requirement here. We have a mutable self. We also have then the system data coming in. So we can say this is our position. And this is also a little bit weird. We're going to be grabbing self system data. And we're not returning anything. This is just going to be our loop through it. And it's self with a capital S. Okay, so this gives us our position, and if we remember, our position is a tuple struct. So to actually access the position, it's gonna be position.0, but and I suppose that I could also try to like destructure it, but it's gonna get a little bit interesting. What's the difference again for like which thing? Self with a capital S and self with a not capital S? I don't have access to self here. So I think self is like the full struct is the type. So it's actually this like type here. Self refers to the struct type. Self is the instant. Yes, exactly. So now I want to loop through. So for, and now we're going to extract again position in and a reference to position, then we dot join this. And now that will give us our position here. Oh, and I think I have to use specs dot join like that. Let's see how close I got. So use specs join. I guess it's colon join. Oh, for position, so it's not. I don't necessarily need the parentheses, maybe. Oh no, I do, because like they're doing restore, so they're not using a tuple here at this point in time in the tutorial. What am I missing from join? No method named join. Okay, use specs join. Read storage and system. I have read storage and system here. As far as you know, self with a capital S is only used for associated types right now. I see self with a capital S used sometimes in some code for like returning the new, like I could say self like that. Why are you upset? What am I missing? Yeah, fancy, like essentially a fancy shortcut, since it's like the type that you're in. I'm not sure I like it though, because then you have to keep in mind like the difference between lowercase and uppercase capital S, and that could be really hard to do, like really easy to miss. So world extends builder. Have those. Component, vec storage. All right. This is like their full example code eventually. Builder component, read storage, system, vec storage, world extension, and run now. Have like everything except run now. And I'm trying to join these together. Is it? So it's saying it can't find. The join method exists, but the following trait bounds are not satisfied. Method not, okay. Is it the reference to position? I didn't think I needed to give it ownership. Maybe I do. Maybe also I could just do this. It's still unhappy about that. This right now is like, I'm putting this in a tuple. I'm not sure it needs to be. Oh, you would not want to be in a tuple. it's saying I'm not using specs join, which I'm trying to use because this is a trait, right? And I'm trying to use it. Try printing it, like printing just position. Oh, maybe it just has to be used, like I'm not actually doing anything in here. Sure, let's print line, and then, so we could debug. We'll debug position. It's not super happy about that. Okay, so let me use the like get this ready. So you don't this is a system, and so we don't register the system, we register components. We can create a new one. So in our game world here, before I return, I would say print position equals print position system, and then print position, we need this run now. And then we pass it a reference to the world. And then we have this like world.maintain, which is not technically needed for this example. I don't think you can join on a tuple. Well, like it has, later on, there's examples that have it with a tuple. So cannot find value print position in the scope. Oh, right, I need to let. We still got this problem where it's like not liking the join that we have. What am I? Do you not want to be, okay, let's, this is a tuple. So we want to like retuple this. Can you destructure position out of self system data? Yeah, that's what I'm trying to do again. Still doesn't have this join. Am I missing anything on that? So component. So struct position, it stores the thing. We set that it's vect storage and that it's a component, which we're doing here with this derive. We have our hello world, which is the equivalent to this print position system. We implement system for print position system. We have our lifetime here. Type system data equals, it's a tuple of read storage lifetime, and then the, okay, the type that we want. We have our function run, mutable self, position, which is a tuple in this case, gets out of self, and then system data. Use specs join. Is there like a different? Can't imagine that would work. Yeah, I think it's join. It's the join trait that we really want here. And then for position in position.join, we then run our debug. This in other examples, I've seen it give like a reference to it. Do you need like a reference here? So method not found. The join method exists, but the following trait bounds were not satisfied. Position, shred world, fetch, inner join. Okay, so we're creating a new world. We're registering position. Did I not do that correctly? World at register, position. Okay. Then we create an entity with a position. And then we build it. Then we get a mutable. Hello world. Okay, so this gets that. And then we run now and pass it a reference to the world. And then we world maintain. You wonder about the derives for component. So let's actually just pull this out. Let's see if I'm missing anything. Okay, let's also like do exactly what they did here. So not going to use the tuple type anymore. Just straight up read stored position. So position is now like this. Use specs join for, in fact, you know what if I go so far as to just replace you entirely with our hello world. It's still going to be position because that's the name of what we have up here. See, now join works. Okay. So print line for position, and this is going to be position dot 0. Which means up here, we now have hello world. Okay, that seems to be working. Let's run this and see if we get a print. I know that is like a sort of a what the moment. It's like, why does that work? What did I do differently? Just not the tuple system data type? I guess so. I must be using that wrong. Okay, so that's done. Let's see. Oh, here we go. Hello, matrix, and then data is 100, 100. So that's like, this is exactly right. We're able to get the, we're able to run that system, which in this case just prints out this. The best part is Twitch forgot to add your mod badge. Yeah, that is interesting that Twitch just suddenly, just for that one message, didn't add a badge in. Okay. I don't know, like, if I switched you to be a tuple now. So you're a tuple, you're a tuple, and you're a tuple. Is everything else, does this still work? Yes. Okay. It says it's unnecessary parentheses because I guess it's like there's only one item in here, which like seems a little bit weird. But like the tuple wasn't causing it to not work. If I just have like a tailing comma, that's what it was. I had a trailing comma. So I had done this. Down there, like that. The trailing comma. Because it's expecting another item in its tuple, it must internally say that the length is 2 now. And so when it iterates over, it just gets nothing at all and can't figure it out. Oh, wow. Like, I did not know that trailing comma could cause that. Put a comma after the positions in the iterator. Okay, so if I do this, for position, comma, position, comma. No, it's still not liking that. Maybe I have to put a... Yeah, that's what it is. Okay, so no trailing commas. Pretty much that's what we've learned. I know that is really weird. But okay, we wonder if it's a unit type with the tuple locations. It might be. I would guess that this is like a weird little thing in Rust about tuples. But okay, so let's get our position. Everything should still work. I want to rename this from Hello World to print location system. And there's our location system working. I don't need to say you. We'll just, I can just run the debug command now. Well, I think before I like add in a velocity system for it to start working in there, do I need to give you a reference? Oh, position doesn't implement standard format debug, so we can fix that. We want you to also implement debug. So before I want to do a velocity system, I just want it to display like a circle in that area. But now we've been able to get the print position here. Let's now see if we can get the print position to work in the update over and over and over again. So we're going to take you, and in update, we're going to have to sort of grab in that structure or the system and create a new system here. And then immediately run it. And then world maintain will also happen in here too. This is now going to be a self.world maintain and self.world here. So can I get it to print out over and over again? Yeah, eventually we're going to move towards a render system. Let's leave this over here so we can see. Okay, so it is printing out all the data for us, so that's perfect. I want to now be able to get, yes, a render system. And we'll run that. So print location, print position is not necessary for us anymore. We know that that's working the way it is. So we don't need you. What I do want is in draw to run now with like it returning, let's just say render circle system. We're going to read the position. We're going to run self position. So we grab this out, use specs join for position and position. Okay, so this is so it's actually going to be this is less of render and more of like it's actually going to draw. So we need the full draw because we can't return from here. So we have graphics. So inside of here, instead of debug position, because we know that we have position with position.0, we're instead going to want to do position, no, graphics draw. Okay, so we need context. And I don't think we actually have access to context. So trick that I saw with Danny is actually creating this, since we have to create this over and over again anyways, we can store context in here like this. Let's see, context. Oh, maybe we can't do the typing in this. Tuples don't get names. Oh, right. So we just get to say it's a mutable context. Which I think it's upset because I'm not using lifetimes. So that means I have to set up lifetimes here, I think. You can use the same lifetime. Is it there? No, I think it's on the other side. It's here, isn't it? Okay, so then draw circle system. We need to say that it's using this lifetime. All right, so I think now that means that our context, we have mute self. We can now just say self dot 0. And I may have to tell it that it's mutable reference. No, it's going to be upset with the rest of these. Okay, so our drawable. So we need, we also need to create, we'll just, for right now, I'm going to create a, like everything in here and overload this run function. And then we can create components to sort of extract things out from here. So let mesh equals graphics mesh builder new. So this is going to be a circle graphics draw mode fill. Our point. So this is, oh, we okay. So we actually need this inside of here because our point is actually part of this position. So we need to say point 2 point 2 from position.0. Our radius, let's just do like 100. tolerance is going to be 0.1. And our color is, we can just say, we actually have a, we have a BBEG color, random right color. Dot build. So now we have to hand it the self.0 for the context. And then we have to dot unwrap this. And that gives us the mesh. And so that means in here, we can now use a reference to the mesh and then have our graphics draw param default dot unwrap. Okay, so no errors in this. I do have one warning. Run now. Okay, right. We're about to run now. So now we're gonna have this draw circle system, and we're gonna do this inside the draw method. So we're gonna say let draw circle equals draw circle system. We have to give it the context. And then we can say draw circle that run now, pass it a reference to self.world. And theoretically, we should get a circle with a random color in it. Oh, and you need to be mutable. Okay, no errors, no warnings. Let's see if this works. All right, it's a random color every single time. So we can fix that, but okay, we've got a rendering system up now. So that's cool. What's next on this? Let's break this out into different components and use multiple components in here so that I'm not creating, like, for example, a mesh in here every single time. So I'm thinking to begin with, let's break out, we have you. Size maybe? So we can break out size, we can break out color, a basic mesh itself. Yeah, I think that's gonna be it. So here's a struct position. Let's create a struct size. Oh, I probably want to do exactly the same thing that I did before. Make this just a tuple struct of F32. Implement size. And I'm going to return size. And here we're going to derive component and also this storage of a vec storage. Okay, so pub function new. So now we tell it, we register it. Scroll.register size. And we can use it here. So dot width size new. And let's just say that this is like, I don't know, if I start you with like 1.0, let's start immediately 100.0, and then I have this idea of like I want to now make that grow bigger. We can pull this. Let's just make it white right now. Or rather, I could just create. Oh, this is still gonna be random. I'll just graphics white. And then the size here. So we need to now say that we want read storage size. And so we're going to be grabbing position and size out of here for position and size in reference to position, reference to size, join them together. And now I can say you are my size. Oh, size.0. Okay, I think this will now set the size to 1. Or like, we're now using the size as a component. Okay, so perfect. Next up would be I want to update the size, and so I can make it grow over time. And I think that's going to be another system. So we're going to say struct grow circle system. Okay, this. Oh, I don't necessarily need that. Okay, so we're gonna implement system for grow circle system. We have our type system data equals, this is going to be our tuple. All we need is write. Oh, we need write storage now because we're mutating it. So write storage. Okay, write storage lifetime size. I'm not caring about the position at this moment. And then we're going to have our function new mutable self. And then we have our size. System data. We're not going to return anything. We're going to use, what is this? Specs join. And now we can have our for loop. So for size in size.join. Crossbow, hello, good morning. What are you upset about? Not a member of trait system. Oh, right, it's not run. It's not new, it's run. No method named join specs. You have to be reference in there like that. Yes, okay. So now we have our size. And I think theoretically I can just mutate this. I need to destructure the tuple. I think, yeah, I'm gonna get, yeah, it's a reference to size. I did it, perfect. I now want to just sort of change it by saying size.0. I'll use plus equals here. Plus equals to like 0.1. Am I resolved on implementing? Are you resolved in implementing random water project? I am investigating ESC as a possible solution. Yes, because I wasn't able to figure that out, and I'm 9 parts in, and I don't want to like keep on going down that path as if it's not working. Do I need to dereference? Yes. So can I dereference you to work? F32 cannot be dereferenced. Wait, is it? Do I not need a reference there? It's a reference to the primary ribbon. Okay, so regardless, it is that. I wonder, can I do this until it's mutable? Cannot borrow size as mutable as it's not declared as mutable. Okay, I guess you are mute size here. Okay. And then, so I create that. And now I just use this system. And it should grow the circles as long as the world maintain runs. So inside of the update here, before this, so we have our draw circle system still, but now we have a let mute grow circle equals grow circle system like this, and then we'll just say grow circle dot run now, and pass it a reference to self dot world. And that works. So I could now set this to be essentially 0.0. So like be invisible essentially. And it slowly grows from nothing. So we have the ability now to sort of make changes. What else do I want to sort of extract out? The color would be nice to extract out. The mesh would be really nice too. So if I could store the mesh, now here's the problem with that. In order to create the mesh, I need the context. I do have a context here. Okay, so let's try this. Let's create. We'll create a component, but instead of size, this is going to be like a mesh component. I'm not using. Yeah, I'm just using mesh off of GGEZ. Okay, so mesh. I might want to say like mesh component. What if I just say circle? You're a circle now. implement for circle, public function new. I don't necessarily need a size. I'm gonna have a circle like this. So let's do let mesh. Yeah, so let mesh. I guess I want you to be like this, and it sort of is a graphics mesh. That's what I'm gonna do. Okay, so let mesh equals graphics mesh builder new dot circle. Okay, so draw mode, we're gonna have this be graphics draw mode fill. Our point, we're gonna create a point to new, sort of like the top left corner. Radius, we're just gonna make this 1.0. Tolerance 0.1, and color. We don't necessarily have this like set up yet, so I'm gonna make it white. Kind of weird that needs the context to make the mesh. I know that does feel a little bit odd. Okay, then we're gonna build, and we have to pass it in, right, the context. Dot unwrap, which means we do need to pull in context. Context there, and then we want to return a circle with the mesh inside. All right, so up in the game world, we're going to register the mesh. So world.register circle. Okay, so with position, with size, dot width, circle new, and pass it in context. So now we're finally using you again. And now in our render, so our draw circle system here, we also need to read. So read storage, circle. So this is gonna be our mesh. And we no longer need this. It's just gonna be a pure draw, but this is gonna get a little bit interesting. So we're gonna have self.0, reference to our mesh, but then our graphics draw params, we're gonna have to do some interesting things here. So our draw params, our destination is now going to be a point to from position.0. And then we're going to have dot scale. I think there's like a uniform. Oh, come on. Scale. Or is it like, I don't remember how it works. Scale, and then scale a vector. Basically, this is just an like literal array slice like this. So it's just going to be size.0, size.0. And the color is the same right now. The trait bound circle drawable is not satisfied. Right, it's mesh.0 now. Okay, no errors. Let's see if we draw circle system. We don't have to change anything else. Let's see if this works. It does, although we get that wasn't really a circle, was it? Did I not? Where's the 0.1? Yeah, it's tolerance is this last one. I wonder if it needs to be like 0.01. Do you draw the circle at 1.0 and scale it? Oh yeah, that's because I don't have the ability to sort of like say like where it is right here. Like I don't think I can override and say like, okay, now I want you to be tolerance of like 0.1. 1.0 is too tiny. I'm scaling it though. Make the tolerance smaller. I could do that. Really small. That might be too small. There we go. It looks like a good normal circle now. All right. So we have like the basics of what we need now. Like we only have one thing. So, but we sort of learned how to get specs to work inside of GGEZ, and we can update things in our update method, and we can draw things in our draw method. And so we're going to have systems for drawing and systems for, I guess like systems for drawing and systems for like updating. And we also have these components that the actual items themselves are using. Now, what I haven't like figured out yet, and I guess like we're gonna have components for like, well, I guess they're not really components, but like how I'm gonna keep track of like what things are the food, what things are the like what types of walkers they are. We'll cross those bridges when we come to them, but I think this is a really good start, and it's going to let us let us move back towards there. Can you explain ECS in a couple sentences? Just a brief overview. Yes, absolutely. So I'll switch over to the whiteboard for that again. So the idea here is we have, with ECS, we're going to move away from storing like a vector of these like almost objects. Like we're programming a very object-oriented method. And each of them would have like a position and a velocity and whatever else it needed to do, along with the methods to update them. Whereas now we're going to move to a vector of like data types, like data sets. So like a vector of all the positions, a vector of all the velocities, a vector of all the sizes, a vector of all the meshes. And so like the first walker is actually going to be a slice down across all of these data structures. And walker 2 is going to be the same across this one. And so that's what's happening when we're doing that loop with the join, is we're saying, okay, take all of these vectors together that I care about, and then join them together, not like left and right, but up and down. So join position 0 of, or join position of 0.0 with velocity of 0 and size of 0 and mesh of 0. Okay, now do the thing. And then it moves on to the next one. It's like, okay, now it's 1 and 1 and 1 and 1. And so theoretically, I'll be able to delete them a lot easier when I get to that point. You can make a component for food and walker behavior enum. Something like a food would also take a vertical slice, but it wouldn't have a velocity. That would be a none. But how you work with entities with different properties. Well, that is exactly what we're going to learn and find out. So I got through the first section of the book this weekend, which gave me basically like hello world, how I'm able to move through the resources, and get access to all of that. I'm probably not going to like immediately go right back into building out the ecosystem project. What I'm probably going to do is build a very basic sort of section of it. So like some moving items. Can I get individual sections of the ecosystem project working, and then we'll rewrite ecosystem project with specs and ECS once we got to that point. How do you work with entities with different properties? Yeah, we'll find out. All right, well, it is 8:14, and that means I'm going to have my stand-up in a few minutes. All components on each entity is optional. When you write a query, you say which entities you want based upon which components they have, don't have. Yeah, and then they'll only give you the data that exists, I think. And there's ways, I think, for you to say, like, don't give me this, too. But I haven't really gotten to that seriously in the book yet. Anyways, thank you everybody for stopping by. I think we're on a better path now for the ecosystem project, and I'm really looking forward to continuing to learn specs and then get that in there, rebuild the ecosystem project, and move on with Nature of Code, but with ECS sort of working with us. So I hope that you all have a great rest of your day, and I shall see you all next time. Bye.